As data scientists, our journey begins with collecting, cleaning, and organizing data. However, before we perform any data analysis, it's essential to ensure we have a deep understanding of the data we're working with. You must be thinking, why is it so important to understand the data and how do we do it? Well, that's what we will discuss in this video. Hi, I am Priyamvada at Fractal Analytics. We will discuss why it is important to know your data and what are some of the steps a data scientist can take to do so. Consider the infamous case of the Therac-25 radiation therapy machine in the 1980s. It was designed to treat cancer patients with precision by delivering radiation to tumors. However, due to software and usability issues, patients ended up receiving massive overdoses of radiation. Do you know the root cause? Poor knowledge of data and data entry errors. Operators who lacked adequate training in understanding the machine's software made mistakes while entering treatment parameters. The machine's software failed to validate the data effectively and provided unclear error messages. As a result, patients' lives were put in danger due to incorrect data entry and poor data understanding. This tragic incident underscores just how vital it is to have a deep understanding of data. Inaccurate data entry, misinterpretation, or a lack of data validation can have catastrophic consequences. Now that we know the importance of understanding the data we are working with, let us explore how we do it. Our first step in understanding data is consulting the domain experts who are well versed in specific fields like CPG, insurance, or whatever domain our data is related to. They possess domain-specific knowledge and provide valuable insights into the data. Their expertise can help us interpret data nuances and guide our analysis. SMEs have a wealth of knowledge in their respective fields, making them invaluable partners in your data journey. They can shed light on industry-specific trends, business context, and potential data sources you might not be aware of. To engage with SMEs effectively, schedule meetings or interviews to discuss the data. Prepare specific questions and objectives to maximize the value of their insights. Remember, the more you collaborate, the richer your knowledge of the data becomes. Our next step is creating a data dictionary. What is a data dictionary? It's like your data's user manual, providing descriptions, data types, sources, and quality notes. Let's delve deeper. A data dictionary is a document that describes the contents, structure, and meaning of your data. It helps standardize data and ensures a common understanding among your team. Here's how to build a data dictionary. Variable descriptions. List each variable or a column in your data frame and provide a brief description of its meaning and purpose. Data types. Specify the type of data for each variable. Example, integers, strings, and dates. Source information. Document where the data comes from, how it was collected, and any potential biases. Quality notes. Include information on data quality issues such as missing values or data anomalies. Finally, let's roll up our sleeves and explore your data frame. This hands-on approach is vital for gaining familiarity with your data. Dimensions. Start by checking the number of rows and columns in your data frame. This gives you a basic understanding of its size. Inspect the first few rows. Use the dot head method to display the first few rows of your data frame. This will give you a glimpse of the data structure and the types of values present in it. Check data types. Examine the data types of each column in your data frame using .info. Ensure that the data types are appropriate for your analysis. For instance, numerical columns should be of type int or float, and categorical columns should be of type object or category. Summary statistics. Calculate and review summary statistics for numerical variables to grasp the central tendencies and spreads. Use the .describe method to get summary statistics for numerical columns. This will give you information about the central tendency, dispersion, and distribution of your data. Missing values. Check for missing values in your data frame using isNull or isNA followed by .sum. Decide how to handle missing data, whether by imputation or removing rows columns with missing values. Understanding your data is the foundation of successful data analysis. By consulting with SMEs, creating a data dictionary, and exploring your data frame, you will be well prepared to make informed decisions throughout your data science journey. However, understanding data is not one step, it's a journey. Later, during data analysis, you will continue to understand the data better. You might create data visualizations to find answers to your questions, and understanding data distributions and relationships between variables will enhance your understanding of the data. Thank you for joining this discussion. I wish you success in your data science endeavors.